In this video, we discuss the Fourier series. Fourier series is the frequency representation for a periodic signal. Let's assume that signal xt is periodic with period t0, which means that this signal repeats itself every t0 second. For example, if this is a signal any shape, it will repeat itself at t0 second. So this is a t0, it repeats itself, and this is at minus t0, it repeats itself, and go on on both sides of the time from minus infinity to infinity. So this is the periodic signal with period t0. F0 we defined as a reciprocal of t0. So F0 equals 1 over T0. We call F0 the fundamental frequency. Before we discuss the Fourier series, let's talk about this complex exponential e to the power j 2 pi f0 t. This complex exponential is periodic with frequency f0. To see that, we use Euler's formula cosine 2 pi f0 t plus j sine 2 pi f0 t. You can see cosine, this term, frequency is f0. This term, the frequency is f0. So therefore, this complex exponential is periodic function with the frequency f0 as well. Then we talk about nth harmonics. Nth harmonic have this format. It can be expressed by e to the power j 2 pi f0 n of t. In this case, the frequency is nf0. So therefore, this is the fundamental frequency, then this is the nth harmonic. Now let's look at the Fourier series. This periodic signal with period t0, in other words, this signal has fundamental frequency of f0. Then this signal can be decomposed as linear combination of all the harmonics. We can see that this n is running from minus infinity to infinity. These are integers. And xn is constant. And e to the power j 2 pi f0 nt, that's nth harmonic. If we expand this summation, we can have this. Because n is running from minus infinity to infinity. Let's see if n is equals to minus 1, then e to the power minus j 2 pi f n minus 1 t. When n equals to 0, that's x naught. E to the power j0, that's 0, and plus x1 e to the power j 2 pi f0 multiplied by 1 by t, and on both sides. This is a DC component. This is a scale strength of the DC components in this signal. This is the fundamental frequency. This is the strength. This term is also the fundamental frequency. That's the strength. And then you go on. How do we obtain this coefficient? The coefficient of x of n, we do integral in one period. This alpha can be anything, can be 0, can be minus half t. And anyhow, this integral happens in one period. So what is the integrand? We take x of t e to the power minus j 2 pi f0 n t and do the integral with respect to t. And then we take the average over the time period t naught, and this is the Fourier coefficient. And this is the Fourier series expression. Typically, the Fourier coefficient is complex, so it has the magnitude, it also has the phase. So next, we are using an example to illustrate. In this example, we show how to calculate Fourier series coefficient for a periodic signal. So ex of t, in this example, ext equals to summation n from minus infinity to infinity, n is integer. Pi, we know pi is rectangular. Argument is t minus n t naught divided by tau. So don't confuse tau and 2 in my handwriting here. Assume that t naught greater than tau. The first step, we want to plot x of t to find t naught, to find the period, in other words. And how do we find out? Because this is written in a compact form of summation. We want to expand it. It is not possible to expand infinite terms, so we look at 3 terms, typical 3 terms. So I call it 3-term rule. So now I expand this summation, writing out n equals to minus 1, n equals to 0, and n equals to 1. And those are 3 typical values of n. Next, we want to plot these 3 waveforms we specified, and then sum them up. To plot this, let's review this pi of t. We know this rectangular. It has value of 1 from minus half to half. Now let's plot n equals 0, pi t over tau. For this point here, we need to solve linear equation. T divided by tau equals to half. We have t equals tau divided by half. So here, that's the waveform for pi t divided by tau. Next, let's look at waveform pi of t plus t naught divided by tau. Again, the same token. To find this typical point, we need to solve this linear equation. T plus t naught divided by tau equals to half. We have t equals to half tau divided by t naught. So that's this point. This critical point is obtained by solving this equation. T plus t naught divided by tau equals minus half. And this point, that's the middle point, that's here, that's 0. And solve this, t plus t naught divided by tau equals 0. That gives us t equals to minus t naught. For this waveform, pi t minus t naught divided by tau, the typical point are t naught plus tau divided by half, and t naught minus tau divided by half. Now we plot them together, plot this waveform together. So there are 3 waveforms. This is corresponding to n equals 0, n equals to 1, and n equals to minus 1. From these 3 typical waveforms, we can see that the period for this function of ex of t is t naught. So the period is t naught. Then fundamental frequency is f naught equals to 1 over t naught. Next, we want to recall the definition of Fourier series coefficient. X of n equals to integral alpha to alpha plus t naught x of t multiplied by e to the power minus j 2 pi f naught nt, and integral on t divided by the period. In this case, we want to choose alpha equals minus half t naught. You can choose any others, no problem. It just choosing alpha equals to this value is a little convenient to calculate the integral. Remember here, we have t naught greater than tau, so half t naught should be here, and minus half t naught should be here. You can see if I choose minus half t naught, n half t naught, I will integrate to this waveform here. Now, because there's 0 on here and 0 on here, so this integral from minus half t naught to half t naught actually becomes from minus half tau to tau, the function value is 1. This can be integral out using this formula, e to the power ax dx equals to 1 over a. This formula, it is in our formula sheet. Because of n, first we need to consider n is not equal to 0, because if n equals 0, you cannot put it in the denominator mathematically. First of all, we assume n not equal to 0, then x of n equals to this. Use this. And a here is this quantity here. Minus j 2 pi f naught n, so 1 over that. And this e to the power ax, the definite integral, half tau and minus half tau. Plug it in everything here. And this is a half tau, and this is a minus half tau. Excuse me for all these pictures. This picture a little blur. I didn't know why. Pay attention that T naught multiplied by F naught equals to 1, because we know F naught equals 1 over T naught. Okay. So therefore, T naught, F naught, T naught, and F naught, that equals to 1. So this term becomes 1 over minus j 2 pi n. And this 2 and 2 cancel out each other. And because there's a negative here and negative, so I flip the sign here. Nothing changed in that step. Next, we want to use the Euler's formula. Sine phi equals 1 over 2j e to the power j phi minus e to the power minus j phi. So this formula is included in our formula sheet, but we want to use it. So therefore, we want to know all of those formulas and know how to use it. We want to look at 2j here. That's 2j here. We want to use this. And all of this, that's phi. This is phi. For that equals to pi of n sine pi f naught n tau. Up to here, this is okay now, but we want to simplify a little bit using sinc function. Recall that sinc t equals to sine pi t divided by pi t. So we want to organize this result a little bit using sinc t. We want to have the same argument here, pi and pi, the same argument, such that we can use the format of sinc t here. I include f naught tau in the denominator. I have to multiply here. This whole box here is a sinc n f naught tau, because a sinc t equals sine pi t divided by pi t. So this term equals a sinc n naught tau and multiplied by f naught tau. Remember that f naught equals to 1 over t naught. I can reorganize a little bit here. So this term, moved it to the front. Tau divided by t naught is sinc n tau divided by t naught. All of this, remember, all of this was assuming that n is not equal to 0. What about if n equals 0? We need to go back to the definition of the Fourier series. This is a Fourier series. When n equals 0, we cannot use this formula. We know that. We want to insert n equals 0 here. For n equals 0, e to the power j 0, that's 1. If we do this integral, that equals tau divided by t naught. But we know that sinc 0, that's equals to 1. Therefore, here we can write 4 and 5 together. That is really sinc function, because sinc 0, it is 1. But the Fourier series coefficient, it is tau divided by t naught, sinc n tau divided by t naught. This is for all n now. We insert the Fourier series coefficient. What is xt? Xt can be written by summation with respect to m and e to the power j 2 pi f naught. Those are harmonics. And plug it in. This is our x of n here. Now let's look at an example here for tau equals to 2, t naught equals to 4. In this case, f naught equals to a quarter, right? Plot this using the 3-term rule. Here, that's the waveform. Here, we can see here the period is 4. And this point is 5 because that's t naught plus half tau, that's 5. And this here, minus t naught minus half tau here, that's minus 5 here. Now we plug it in, all of this tau and t naught, that equals to half sinc half e to the power j 2 pi f naught and t. Remember, f naught equals a quarter, that equals e to the power j pi over 2 n of t. Then this portion, that's the Fourier coefficient. Now let's look at a few typical value of the Fourier coefficient. For n equals 0, sinc 0, that's 1, right? X naught equals to half. And x1, that's sinc half divided by half. Then for n equals to 2, x2 equals to half sinc 1. Sinc 1 equals 0 because sinc function for integer values, that's 0. And then we can obtain for n equals to minus 1, x minus 1, that equals to half sinc minus half. And this is the same, half, that equals to sinc. Remember, sinc function is symmetric. We have sinc minus x. I use different symbols. Sinc minus u, that's equals to sinc u. For n equals to minus 2, that's equals to 0. The Fourier series coefficient for frequency 2f naught, minus f naught, 4f naught, and minus 4f naught are all 0. What is the physical meaning for this? That means harmonics of even orders does not appear in this signal.